In the world of industrial design, some of the worst two words you can hear are unplanned downtime. In other industries, those words can mean a slight annoyance or maybe a little worse. But in terms of industrial applications, those dreadful words mean a full stop, and that is never a good thing. One way to combat unplanned downtime is CBM, or condition-based monitoring. But until recently, CBM wasn't really an option for the bulk of industrial designs. Fortunately, that has changed. Hi, I'm Amelia Dalton, host of Chalk Talk. For today's increasingly connected industrial designs, condition-based monitoring has become more popular than ever before. In today's Chalk Talk, Morris O'Brien from Analog Devices joins me to discuss the newest in CBM solutions from Analog Devices, including sensing modalities, edge processing, power management, and asset monitoring. And before we get started, don't forget to click that link. There you can find even more information about this topic from Analog Devices. Hi, Morris. Thank you so much for joining me.
Great to be here.
Okay, so we're talking about industrial CBM solutions today. But Morris, before we get started, what is driving growth of CBM?
Sure. So first of all, what I would say is that, industrial CBM is nothing new. Industrial CBM has been around for quite a long period of time. But what's different is the broadening of the scope of the applications of condition-based monitoring. Traditionally, condition monitoring was deployed on the most critical assets, or what I would call the 5%. So these were assets in a manufacturing capability that if they failed, everything would stop. So examples would be power generation, a compressor, pumps for water or fuel. So those critical assets were always monitored. But what we're seeing now is people are seeing the value of condition-based monitoring, and they want to deploy it on more assets, on the other 95% of assets across that manufacturing capability. And that's really what's driving the growth. From an end market perspective, as are listed here, the types of applications where we see condition monitoring are smart manufacturing, water, wastewater treatment, food and beverage, paper and pulp, metal and mining, energy, oil and gas installations, and smart logistics. So as we deploy condition monitoring in those end markets, as you will see from the icons, as I move from left to right is where I'm talking about the growing of the applications. Traditionally, it was the rotating equipments, the pump, the drives, the compressors, but now we're seeing condition monitoring in machine tools, conveyor belts, robotics, and instruments as examples of the newer applications.
Okay, so Morris, what is the impact of deploying a CBM solution?
So it really centers around the cost of downtime. This is the key driver for the condition monitoring applications these days. And there was a very interesting report published back in April of 2018 from the Cost and Benefits of Advanced Maintenance in Manufacturing by the US Department of Commerce. And it called out the fact that almost 1/4 of total manufacturing cost is associated with unplanned downtime. Therefore, with the deployment of new condition monitoring applications and predictive maintenance service offerings, we have the potential to eliminate this cost.
Okay, so Morris, what technologies or capabilities specifically does Analog Devices bring to CBM?
So from an analog devices perspective, we are really focused on delivering solutions from sensing to AI-enabled actionable insights. Analog Devices as a company has been in existence for a little over 50 years, and we bring a very broad base of technologies to condition-based monitoring applications. So I'll briefly walk through the different technologies. First of all is sensing modalities. One of the key sensing modalities is vibration and shock detection. And Analog Devices was a pioneer in MEMS-based sensing technology over 30 years ago. We've shipped over 1 billion of these sensors, and these are a fundamental sensing modality on an asset. Also, temperature sensing is important. And then for any analog output sensing modality, we need to bring that information into the digital domain. So we need high quality or high fidelity data acquisition solutions based around precision converters, amplifiers, and references. And once we have this asset health information in the digital domain, we're deploying edge processing to create asset health data that we then need to communicate across the plant or a manufacturing capability. There is a wide range of various wired and wireless connectivities. For example, on the wired side, we have IEPE or 4 to 20 milliamp, RS-45, CAN, LVDS, and new single pair Ethernet technologies like 10BASE-T1L that can provide both power and data on a single twisted pair cable. We also have isolated transceivers. And then on the wireless side, we have sub-gigahertz, 2.4 gigahertz smart mesh technology. And then we also need to power all of these various components. So Analog Devices is leveraging its very broad-based power management portfolio around power regulation, protection, references to provide the power solutions to power our sensing, data acquisition, edge processing, and connectivity solutions. But most importantly, where ADI is most focused on is combining these technologies in what we call asset monitoring solutions. So this is where we are providing our customers reference designs and platforms that allow them to quickly evaluate these technologies and ultimately accelerate their time to market. And then the last step is to take the asset health data and transform it into asset health insights. We also have to help our customers how to use the data with a view to making decisions on whether or not an asset needs to be serviced or if it needs some components to be replaced. And that's where ADI AutoSense sits in as an AI platform to interpret the data. But as you can see, Analog Devices is in a unique position in terms of the breadth of our offering to be able to provide an end-to-end solution for condition monitoring applications.
That makes sense. Now, Morris, can you talk a little bit more about asset monitoring solutions from Analog Devices?
Sure. It's a really important topic for us. Again, how we combine our technologies, how we present our technologies out to our customers is really important. And that's probably one of the most impactful things that we as Analog Devices do in terms of making sure that we are developing best-in-class reference designs and platforms that ultimately we engage with our customers on in terms of accelerating their hardware development. And that's really the left-hand side of this slide. So on the left-hand side, we start at the bottom and we move upwards. So on the bottom left, we have circuit nodes. A circuit node is where ADI is providing a hardware solution that is proven in the lab where we're showing combinations of our technologies. So for example, CN0532 is where we showcase our industry-leading MEMS sensors like ADXL1002 with an IEPE interface. IEPE stands for the Integrated Electronic Piezoelectric Interface. So this would be used by customers who potentially want to replace piezo sensors. CN0533 is very similar, but in this case, it's a 4 to 20 milliamp interface. CN0540 is a circuit node that showcases Analog Devices high fidelity data acquisition solutions. In this case, it's a IEPE interface, and it's got a 24-bit data acquisition solution. So these are our reference designs. And then as we step up on the left-hand side, we're adding more capabilities. So as we step up to the signal chain module, this is where ADI is solving more than just the sensing and signal chain challenge. We're also solving the mechanical. And as we look to deploy higher performance condition monitoring solutions, and I'll be more specific, as we look to deploy MEMS sensors that can sense up to 10 kilohertz, the mechanical coupling of that MEMS sensor to the asset becomes really important in order to sense those very small vibration signatures that allow us really to have a high impact condition monitoring solution. So ADI provides solutions that have mechanical proven enclosures. And the example here is the AD-CM XL3021, which is a 3-axis 10 kilohertz MEMS sensing solution with a digital interface. And again, as we step up a little bit higher, we talk about signal chains and communication solutions. So here we show an example of a wired vibration monitoring platform which again showcases our MEMS vibration shock detection sensors with an RS-45 interface. And then the other example is a wireless vibration monitoring platform based again with our MEMS technology for sensing, but in this case, the connectivity is smart mesh. And then the next step up at the algorithm development level is an example where we are providing all of the signal conditioning, the MEMS, the data acquisition, and the processing, whereby we provide all of the hardware solution. And basically, with this platform, we present high quality vibration data. We've abstracted all of the hardware challenge, and we allow our customers to focus more on how to use this high quality vibration data to generate their own algorithms. So that's some examples of our reference designs and platforms. On the right-hand side is talking more about deployable solutions. So this is where ADI itself is providing a product which can be mounted on an asset, and with no additional R&D, you have a deployable solution. So examples here are ADI AutoSense, and we've also partnered with some companies like AMC to provide more RS-45 connected solutions. I'd also like to take the opportunity just to take a little bit more of a detailed look at two of those platforms. So the first one I'd like to look a little bit more at is what we call the Voyager 3 platform. This is a robust, low-power, wireless mesh vibration monitoring platform. As you can see from the image in the center here is that this is a fully complete platform. So first of all, it is designed in an IP housing. It comes with a proven mechanical mounting stud at the bottom so that it can be mounted directly onto the asset. From a sensing perspective, it's based on our ADXL 356, a very low noise, low power, 3-axis MEMS sensor, coupled with our low power ADC technology. Also features the ultra low power ARM processor to process the data, but most importantly, is based around a very robust, very low power smart mesh connectivity. So this platform, is a very popular platform for our customers, particularly for those customers where maybe condition-based monitoring is new. They're looking to add this capability to their assets. And by leveraging a platform like this, it's a fully encapsulated enclosure, something that they can mount directly onto the asset and just start generating data and showcase the value of condition monitoring to their end customers. The second example is around a wired platform. And in this case, it's the CN0549. So this wired platform is focused on the IEPE, which I mentioned earlier, the Integrated Electronic Piezoelectric Interface. And again, this is a complete development platform where ADI is solving all of the hardware challenges. So let's take a little bit deeper look at what are the components of CN0549. First of all, it features a wide bandwidth vibration sensor up to 10 kilohertz. And it also comes with a mechanically proven mounting cube. And as you will see, this cube provides the flexibility to mount the sensor or that PCB on any one of the faces of the cube so that you can use the MEMS sensor on different axes quite easily. As I said, it's based on the IEP interface, and it also has the data acquisition card to bring the IEP data and bring it into the digital domain. And this is centered around a 24-bit data converter from a Sigma Delta capability. And this is paired with one of two FPGA cards. So we have a FPGA board, which is more from the Xilinx side, and we also have one from the Intel side. But ultimately, the combination of the sensing, mechanical cube, data acquisition, and FPGA processing card means that we can take care of all of the hardware options required to bring a high quality vibration data and process it locally. And then the final step is to bring this high quality vibration data into the data analysis tools with a view to being able to create algorithms with that data. So this platform also supports software bindings to bring the vibration data into MATLAB, Python, TensorFlow as examples of the data analysis tools.
Excellent. So, Morris, what is the impact of these platforms for customers with a view to reducing development time?
Yes, so ADI puts a lot of focus, a lot of effort around these development platforms like Voyager 3 or the CN0549. because we see the impact of them in terms of the accelerated development that they provide to our customers. As I said, there are a lot of customers where condition-based monitoring is new. And often when we engage with them, it's at the research stage. And by leveraging one of these platforms, it really allows our customers to move that project from a research stage into a more of a committed development program. And that's where I talk here about these platforms being able to demo to management. And in this case, it's to our customers' management, the value of CBM, and to their end customers, the value of CBM, with a view to accelerating development and the ultimate sale of these new devices. So we have engaged with some of our customers who have looked at these platforms with a view trying to understand what is the impact from their perspective in terms of the reduction in development effort. And we looked at, for example, the circuit note CN0549, and the feedback was, a platform like this would reduce somewhere between 2 to 3 months of development effort, and a more complete platform like the Voyager 3 wireless CBM platform, given the fact that this comes in an IP-rated enclosure and it can be mounted directly onto the asset. The impact here is probably in the region of 4 to 6 months reduction in development effort. So the impact of these platforms really is, I think it's quite impressive. And as I said, it's a key area that ADI focuses on in terms of helping our customers get to market faster with the condition monitoring.
Excellent. Well, Morris, I think that's all I have time for today. Thank you so much for joining me.
Thank you for the opportunity.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Analog Devices. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it. It's right across the top. Or head on over to YouTube, youtube.com/EE Journal.